Welcome to this new module in Azure Administrator course, and in this module we'll be talking about writing JSON Azure Resource Management Manager or ARM templates using Visual Studio Code. In this module you'll learn how to define and deploy your Azure administration infrastructure as code, ensuring consistency, reliability, and scalability. Whether you're managing a single resource or an entire environment, ARM templates provide a powerful way to automate and standardize your deployments. So let's get started. And we'll start looking at learning objectives for this module. So by the end of this module, you'll be able to implement a JSON ARM template using Visual Studio Code, leveraging its powerful editing and validation features. You'll be able to declare resources in your template, adding flexibility by incorporating parameters and outputs to customize deployments. And of course, these skills will enable you to deploy infrastructure to Azure in a repeatable and efficient manner. Speaking about prerequisites for this module, please ensure that you have everything you need. You'll need to have some familiarity with Azure because you should be comfortable using the Azure portal and understand subscriptions, resource groups, and resource definitions. As well as you'll need to have an active Azure account. If you don't have one, you can create a free account to follow along. You'll need to have an access to Visual Studio Code. Go ahead and install this lightweight, powerful code editor locally. And you'll need to add Azure Resource Manager Tools extension to Visual Studio Code for ARM template validation and IntelliSense support. Also, you'll need to have some Azure CLI or PowerShell knowledge and access to Azure CLI or PowerShell. Install one of these tools to deploy your templates from the command line. So with these tools in place, you're ready to start building and deploying ARM templates. And let me remind you that this module is part of several learning paths, including Administrator Infrastructure Resources in Azure, Architecting Compute Infrastructure in Azure, and AZ 104 Prerequisites for Azure Administrators, which prepares for the Azure Administrator Certification hands-on skills. So by mastering ARM templates, you'll gain a critical skill for deploying and managing resources in Azure, whether you're an administrator, architect, or developer. Ready to start? Let's turn your infrastructure into code and unlock the power of automation in Azure. So in this lesson, we'll explore Azure Resource Manager or ARM templates. It's a powerful tool for implementing infrastructure as code. ARM templates allow you to define and deploy your Azure infrastructure using JSON files, ensuring consistency, scalability, and efficiency. By the end of this lesson, you'll understand the structure of ARM templates, how to deploy them, and the benefits of using infrastructure as code. Now, what is infrastructure as code? Infrastructure as code, or IaaC, is the practice of managing and provisioning infrastructure through code rather than manual processes. Instead of configuring services or servers, networks, and other resources by hand, you describe your infrastructure as code files. This approach offers several advantages. Let's take a look at the key benefits of this approach. First off, consistent configurations. You eliminate manual errors by defining infrastructure in reusable, version-controlled code. Then improved scalability. You easily replicate environments for testing, staging, and production. Of course, faster deployment, because you automate resource provisioning and reduce deployment times. And of course, better traceability. You can track changes to infrastructure through version control systems like Git. So ARM templates are a key tool for implementing infrastructure as code in Azure. They enable you to define and deploy resources in a declarative way. Let's take a closer look at ARM templates. Let's explore ARM templates, which are a foundational tool for deploying and managing infrastructure in Azure. ARM templates are JSON files that define the infrastructure and configuration for your deployment. They use a declarative syntax. Declarative syntax simplifies the process of defining what resources you need without worrying about how to create them step by step. Take a look at my screen and see how this declarative syntax looks like. If we minimize this declarative syntax example and maximize imperative syntax for you to compare the difference between declarative and imperative syntax. So if we click on imperative syntax, as you can see, it looks as follows. So now you can see the difference between declarative syntax, here it is, and imperative syntax, here it is. Now, declarative syntax focuses on what you want to create. You describe the desired state of your infrastructure and the system figures out how to achieve it. For example, I need a virtual machine with 4 CPUs and 16 gigs of RAM. While imperative syntax focuses on how to create resources by specifying each step in the process. For example, run this command to create a VM, then run this command to configure its CPU and RAM. Now, ARM templates use declarative syntax, as I've said, allowing you to define the end state of your infrastructure without detailing the steps to get there. So how ARM templates work? Let's take a look on my next slide and see the ARM template structure. So Azure Resource Manager template structure follows a clear and organized format. As I've said, the template uses JSON syntax to define the infrastructure components and their configurations. Each ARM template contains several essential sections that serve specific purposes. Schema declaration specifies the template version, ensuring compatibility with the Azure Resource Manager service. This helps maintain consistency across different Azure API versions. Then the parameters section allows for template customization during deployment. Teams can reuse the same template across different environments by adjusting parameter values. This flexibility supports efficient resource management while maintaining standardization. Now, variables in ARM templates store reusable values and expressions. This helps reduce repetition and simplify template maintenance. The resources section, the next one, defines the actual Azure components for deployment, such as virtual machines, storage accounts, and networking components. Now, the service processes these definitions to create or update the specified resources in your Azure environments. Each resource definition includes required properties like name, location, and specific configuration. And the outputs section returns useful information after deployment completes. Teams often use outputs to retrieve resource identifiers, connection strings, or other values needed for subsequent operations. Now, why do we use ARM templates? The implementation of Azure Resource Manager templates provides significant operational advantages for organizations. Let's take a look at the key benefits that make ARM templates a strategic choice for infrastructure deployment. So, first off, it provides a consistency-first principle. When you create an ARM template, it serves as a reliable blueprint for your infrastructure. This means you can deploy the same configuration repeatedly across different environments, ensuring identical setups every time. From a scalability perspective, ARM templates enable rapid environment replication. The template structure allows for parameter-driven deployment, which means you can use the same template to create deployment, testing, and production environments. This capability reduces configuration errors and speeds up the deployment cycle. Now, the efficiency gains from using ARM templates are substantial. Rather than performing manual steps for each deployment, the automated process handles resource provisioning. This automation significantly reduces deployment time and minimizes the risk of human error during setups. So these three capabilities or benefits, help ensure that your infrastructure deployments are reliable and maintainable. Teams can focus on improving templates rather than troubleshooting deployment inconsistencies. Now, let's explore a practical implementation of Azure Resource Management templates through a web application deployment scenario example. This setup requires three main components. The first one is a virtual machine, the second component is a database, and finally a storage account. The virtual machine serves as the web server hosting the application. When configuring this virtual machine, we specify its size as standard DS2 v2, for example, and select Windows Server 2019 as the operating system. This configuration provides sufficient resources for a standard web application. So if we take a look at the template itself, here we specify first off the type. The type field specifies the type of resource being defined here. Here it's virtual machine under the Microsoft.compute namespace. This tells Azure Resource Manager exactly what kind of resource it creates. Then we specify the name. The name field specifies the name of the resource. Instead of hard-coding the name, it references a variable, which is VM name in our case, and it's defined elsewhere in the template. Using variables makes the template reusable and easier to maintain. Then we specify resource location. The location field specifies the Azure region where the resource will be deployed. It references a parameter location that can be passed into the template during deployment. This allows you to deploy the same template to different regions without modifying the field. And finally, we specify dependencies. The depends on field defines dependencies between resources. In this case, the virtual machine depends on a network interface or nickname here. So it should be created first. Azure Resource Manager uses this information to deploy resources in the correct order. And the resource ID function dynamically generates the unique identifier for the network interface resources. So this particular ARM template is using, and all the templates, by the way, are using, let me remind you, declarative syntax. Here we define what we want, a VM, and its properties, and not how to create it. We can reuse this template, and we can use dependency management here. So the depends on field ensures resources are deployed in the correct order. But let's go on to our next component here. It's a database component. Again, this component uses Azure SQL Database for a standard S0 tier, and this section offers a good balance of performance and cost for typical web applications. This database stores application data and user information securely. Again, we are using the template for this component. For storage requirements, we're using or implementing a general purpose V2 storage account with local redundant storage or LRS. This storage solution maintains application assets, logs, and backup files. So this ARM template defines these resources with their specific configurations and dependencies. The template ensures that resources are created in the correct order. For instance, the virtual machine deployment waits for the network interface creation to complete. And of course, this approach simplifies the deployment process here. Instead of configuring each resource separately through the Azure portal, a single template deployment creates and configures all components automatically. And such a solution is flexible through its parameters. The template allows modification at resource names, locations, and sizes without changing the template structure. And we can of course then reuse this template across different environments. So let's quickly review the key benefits of using Azure Resource Manager templates for deploying and managing your cloud infrastructure. As I've said, ARM templates enable you to automate deployments and adopt the practice of infrastructure as code, making your infrastructure management more efficient, reliable, and scalable. So ARM templates allow you to define your infrastructure in code. This means your infrastructure setup becomes part of your development projects, just like application code. You can store these templates in a source repository such as GitHub and version them alongside your application code. And again, to remind you, this approach ensures consistency, traceability, and collaboration across teams. One of the standout features of ARM templates is their idempotency. This means you can deploy the same template multiple times, and the result will always be the same. Your resources will be in the desired state. This eliminates the risk of inconsistencies and ensure predictable outcomes. Resource Manager, the engine behind ARM templates. It orchestrates the deployment process. It ensures resources are created in the correct order, handling dependencies automatically. Additionally, Resource Manager creates resources in parallel whenever possible, making deployments faster compared to the traditional scripting methods. Now, unlike scripted deployments, which may require multiple calls to process individual setups, ARM templates require only one call to process the entire template. This streamlined approach reduces complexity and improves efficiency. Now, Resource Manager includes built-in validation to check your template before deployment. This validation ensures that your template is syntactically correct and that the resources can be deployed as intended. By catching errors early, ARM templates help prevent deployment failures. Then, as your deployments grow in complexity, you can break your ARM templates into smaller, reusable components. These smaller templates can be linked together during deployment or nested within other templates. This modular approach promotes reusability and simplifies maintenance. As you can see on my screen, you can break a larger template into smaller ones such as storage template, network template containing virtual network and subnetting, and compute template containing virtual machine resources and NIC resources. Now, if we go to the next slide, we can see that we can utilize deployment history and monitoring when using templates. The Azure portal provides a detailed deployment history, allowing you to review past deployments and their outcomes You can here see the values of all parameters and outputs, making it easier to troubleshoot and audit your deployments. Moving on to integration, the templates within CI/CD pipelines. ARM templates integrate seamlessly with continuous integration and continuous deployment. Tools like Azure Pipelines. This integration enables you to automate your release pipelines, ensuring fast and reliable updates to both your applications and infrastructure. So by combining Azure DevOps with ARM template tasks, you can achieve end-to-end automation for your projects. So we can go through each of these steps. First, source control. It stores ARM templates in Git, version control for infrastructure, and pull request validation here. Then build step, template validation here, parameter file generation, and artifact publishing. Then test step, deploy to test environments here, integration testing and validation checks here. And finally deploy. Here we deploy to production. Here we've got rollback capability and deployment validation step. So as you can see, ARM templates offer a powerful way to manage your Azure infrastructure efficiently, from enabling infrastructure as code to ensuring implement deployments and seamless CI/CD integration. ARM templates provide the tools you need to build, deploy, and manage your cloud resources with confidence. In this demonstration lesson, we'll explore how to deploy an Azure Resource Manager template to Azure using Azure CLI. I personally use it on macOS, so if you are following along on macOS, you'll need to install Azure CLI. To do this, just type brew install Azure-CLI. If you are running on Windows machine or Linux machine, in previous modules I've demonstrated how to connect to Azure using your local client with Azure PowerShell modules. So to follow along, you'll also need to have an active Azure account. As you can see, I've successfully logged in here. I've typed, let me scroll up to find this command. So first I've typed brew install Azure CLI, as you can see here. It updated my brew packages and installed Azure CLI. Then I've typed this command az login. It redirected me to the browser where I could use my Azure credentials to log into my account. And then when I've successfully logged in, it retrieved tenants and subscriptions for the selection, and now it asks me to select a subscription and tenant. So I can go ahead and select number 1. That'll select my only one subscription. Now, if I list the contents of this directory, this demo directory, it's an empty directory right now. So let's go ahead and open a text editor. We can use VS Code, as I've said, or some other text editor to create a template with .json extension. So we'll create a new file and save it here. So let me open my Visual Studio, and I've already added this directory, this demo directory, to my Visual Studio. Now we can go ahead and create a new file and name it, for example, template.json, like so. So we've got our file in place. Let me make it larger like this and minimize the Explorer and close this welcome window. Now we can go ahead and create our template here. So I'll copy the first file, the first 2 lines, and paste them here, not to type such a long path for schema. Here it is. It's an a sample piece of code, and let's hit return after this comma. That will automatically indent at the appropriate indentation to continue this file. So I haven't run this file yet, so we're doing this together. Let's continue creating this JSON file. We'll add in double quotes content version. So we'll type content version. As you can see, Visual Studio offers us, with the help of IntelliSense, the auto completion. So I can hit tab here to auto complete this piece of code and now provide the version, for example 10.0.0.0. Then to add this line, we'll need to add a comma here and hit return. Again, will be placed into the appropriate place with auto indentation, and we can go ahead and add resources field, again autocomplete, colon, then we'll add resources in square brackets. We'll separate it from this line, hit return here, and here we'll need to add curly braces, again hit return here, and add the first resource, and that will be type, for example, Microsoft. As you can see, we've got IntelliSense hints here, so Microsoft, let me finish this work, Microsoft dot, let's say storage, so that will be from uppercase letter, storage, not storage, sorry, but storage, and then / storage accounts. Then add a comma here and add API version field or resource, for example 2021-04-01, comma, name, let's name it, for instance, lead ARM demo. To be it unique, we'll add a comma here to finish this line. Now we'll add location, colon, and let's use in square brackets resource group, empty parenthesis, dot location, double quotes, and double quotes here. And we'll add a comma here. Also, we'll need to add sku, colon, and again, let's make it multi-line with curly braces. Again, we'll add sku name, for example, in double quotes, standard underscore LRS. Now to finish this line, we'll add a comma here after closing curly brace and add a kind field. Let's make it storage v2, here it is. Again, comma to finish this line, and properties, colon, let's add an empty curly braces here. Now after this closing curly brace of the whole block, we've got our closing square bracket, and we'll need to, let me make it smaller like this, so we'll need to add a closing curly brace here. As you can see, it closes this curly brace. So now we've got several blocks. We can minimize all these blocks like so, or maximize them, containing all items we want to have in our template. So this template creates a storage account named lead ARM demo in the same location as the resource group. Now I haven't created a resource group yet. So now let's define and create a resource group. As you remember, resource group is a container for your Azure resources. You can use an existing resource group or create a new one. I'll be creating a new resource group with AZ command, so let me switch back to my terminal, clear the screen here, make it larger, like so, and we'll type AZ group create. Now to continue this command from a new line, so that will be a multi-line command, we'll type backslash like so, hit return. Well, it doesn't work here. Let me clear the screen and rerun it. So let's type the whole command here. We'll provide dash dash name. Let's name it lead RG resource group demo. And we'll provide a location here. For example, East US in double quotes. Hit return, and that'll create a resource group that will take some time. Now, as you can see, we've got an output that resource group is created with the name lead RG demo. Now, we can go ahead and continue with deploying the ARM template. And by the way, here, if you don't know the location you want to use, you could use, let me clear the screen, you could use AZ account list dash locations. That will reveal the available locations. Oops, seems like I've made a typo here in account, so account with double C, list account, AZ account list locations. And as you can see, we've got a long list of various locations we can use. But I've created in the resource group in East US, and if I type AZ group list, that will reveal the, again, I've made a typo here, sorry for that, let me correct it, group list, the correct command, that will get the available resource groups in my subscription. As you can see, we've got lead RG demo group here. Now, with that said and with that done, let's go ahead and deploy the ARM template we've pre-created. So to deploy the local ARM template, we could use the following command. Let me clear the screen here and type the following. Let's create a variable containing our template. So let's create some template file containing the following. The path to our template, which is located in our current working directory. So that is users show me demo /template.json file. And we've got an error here. That's because I'm using PowerShell here. Let me exit from here and change to demo directory like this and rerun this previous command. Actually, I'll need to copy this command, so I'll select it. I cannot rerun it because now I'm using different environment, so let me rerun it. So now we've got template file with the path to the file itself. Now let's run the deployment command. The command looks as follows: AZ deployment group create. And by the way, that's why these backslashes didn't work, because we were running in PowerShell environment, and in PowerShell we use this tick to go to the next line. And here in Bash we use, actually it's not Bash, it's the shell here on macOS, but it works similarly. So we use backslash to go to the next line like this, and we'll need to give it a name. Let's say that it will be lead deploy demo. Again, we'll go to the next line and we'll provide the resource group, which was, as far as I remember, lead RG demo. And the next line, we'll need to provide the template file itself. We'll be using a variable which we've pre-created, which name is template file. So let's give it a try, and we get an error: unrecognized argument template file. Okay, that was a typo again. Let's rerun this command. Template file. One more try. Failed to parse users demo template JSON. Please check whether it is a valid JSON format. Let's double check our file here. And seems like I'm missing this extra 0 here. Let's correct it and rerun the previous command once more. Hit return. So now it takes a bit more time, and as you can see, it began to run this template, and I hope that it'll work this time. Now it has completed deploying this template, and we can go ahead and verify the deployment. So after deploying the template, it's a good practice to verify that resources were created successfully. So let me clear the screen here and type AZ storage, as we've created a storage account, show. We could also add name. As far as I remember, it was lead deploy demo. Let's try this one. And we'll need to provide the resource group as well. So dash resource dash group. It was lead rg demo. And this one doesn't work as well because seems like I'm missing storage account before show. Let me clear the screen and rerun this previous command. Go to this line. Is this storage account show? It wasn't found. Seems like I'm missing the name. So let's go to the GUI version and double check there. Now I've switched to my Azure portal, and if I go to storage accounts here, I'll find this my lead arm demo. Sorry, the name was lead arm demo. So I've forgotten the name I've created it with. So as you can see, we've successfully completed this demonstration where we've successfully implemented an ARM template which creates a storage account in a specified resource group, and we've also confirmed that it was created successfully. Now, for advanced deployment options or more complex scenarios, you could consider linked templates or CI/CD pipelines, which will automate deployments using tools like Azure Pipelines or GitHub Actions, and these pipelines streamline the deployment process for ARM templates. That'll conclude our demonstration. I hope it was informative, and I'd like to thank you for viewing. In the previous unit, you created an Azure Resource Manager or ARM template and added an Azure storage account to it. However, you might have noticed a limitation. The storage account name and SKU were hard-coded. This means the template can only deploy the same storage account every time, which isn't practical for real-world scenarios where different environments require unique configurations. To address this, ARM templates support parameters and outputs, which allow you to create more flexible and reusable templates. In this lesson, we'll explore how to use these features to make your templates adaptable to various deployment needs. Now, what's the problem with hard coding? Hard coding values like the storage account name or SKU limits the template's usability. For example, you can't deploy the same template across different environments. For instance, development environment, test, and production environments, without creating multiple versions. Changes require manual edits to the template, increasing the risk of errors. Now, to solve this, ARM templates allow you to define parameters. Parameters are inputs that can be provided at deployment time. So ARM template parameters allow you to customize your deployments by providing environment-specific values. This flexibility ensures that the same template can be reused across different environments, such as deployment, test, and production, by simply adjusting the input values. For example, if your template creates a storage account like we did in previous demo lesson, you can parameterize the storage account SKU. For example, standard underscore LRS, so that it can be specified during deployment. This approach enhances reusability and adaptability. So when configuring parameters, you define their type. First off, you also define allowed values and default settings. The service, Azure Service, supports various parameter types, including string parameters, as you can see in this example, integer parameters, arrays parameters, and object parameter. This parameter type serves specific purposes in your template configuration. The service processes these parameters during deployment, replacing placeholder values with the specific inputs you provide. This mechanism ensures consistent resource deployment while maintaining flexibility. Parameters commonly define settings such as resource names and tags, storage account SKUs, virtual machine sizes, network configuration, and resource locations. Let's take a look at our example and explore how to parameterize a storage account SKU in your template. So the template structure includes a parameters section where you define the configuration values, as you can see on my screen. For storage account SKUs, you can specify allowed values to ensure valid configurations during deployment. And the parameter definition includes several key components here. First off, the parameter type. We can set it, for example, to string. Then the default value provides a fallback option. Then allowed values which restrict the parameter to valid SKU options. And we've got several valid SKU options here, namely 4. And metadata description helps other users understand the parameter's purpose. So when deploying this template, you can specify the SKU value using the Azure CLI. The command structure provides a clear way to pass parameter values during deployment. Let's take a look at how the command could look like. So as you can see on this example, we can pass the parameter value during the deployment. In this case, we are passing this storage account SKU, which is standard GRS. And here in our example, we've got available SKU options, which include standard LRS or local redundant storage, standard GRS or geo-redundant storage, standard ZRS or zone redundant storage, and premium LRS, which is premium locally redundant storage. So we can pass any of these parameter or option. These options provide different levels of data redundancy, as you remember from our previous modules, and performance characteristics. The choice of SKU depends on your specific requirements for data accessibility, durability, and cost consideration. So this parameterization approach allows you to use the same template, this one, across different environments while adjusting the storage configuration as needed. And this built-in parameter validation ensures that your supported SKU values are accepted during deployment. Now let's take a look at some recommendations for using parameters. So use parameters for settings that vary according to the environment. For example, SKU size or capacity. Also use parameters for resource names that you want to specify yourself for easy identification or to commonly comply with internal naming conventions. Provide a description for each parameter and use default values whenever possible. So let me switch to the next slide with parameter best practices and again, environment-specific settings. Use parameters for setting the vary across environments such as SKU size or capacity. Let's take a look at this example. For example, a deployment environment might require fewer resources than a production environment. And by parameterizing these values, you can reuse the same template across different environments without hard coding specific details. So here the VM size parameter is used to define the size of virtual machine, which is setting the often varies depending on the deployment, development, testing, or production. And by parameterizing this VM size value, the template becomes reusable across different environments without requiring modifications to the template itself. So here we are avoiding hard coding values, making the template adaptable. And here we also allow users to specify the VM size based on their needs. For example, if they need smaller VMs for testing and larger VMs for production. Next, in this example, let me make it larger like so. We specify the default value, which is set to standard D2S_v3, which is a reasonable default for many scenarios. So it simplifies deployment by reducing the number of inputs required from the user, defaulting to this one. And it also acts as a fallback if the user does not provide a specific value here. It ensures the template works out of the box without requiring extensive customization. We also include a clear description here. The metadata parameter field includes a description that explains the purpose of the parameter. It provides clarity for users who may not be familiar with the template or helps users understand what values to provide. For example, a valid VM size. And it also involves maintainability by documenting the parameter's purpose. Now, the type parameter here is set to string, which is appropriate for VM sizes since they are typically represented as strings. For example, standard D2S. It ensures the parameter accepts valid input formats and prevents errors by enforcing the correct data type. So if we minimize it, make it smaller like this, and go to the next section here about the sensitive information, I must say here, let me switch to the previous slide, never hard code credentials or secrets in templates. Always use secure string or secure object for sensitive data. So let's get back to this slide and see the example here. So again, never hard code sensitive information like passwords or secrets in templates. Always use parameters to pass such data securely. So here, the admin password parameter is defined to accept a password, ensuring that the value is not hard-coded in the template. This allows the password to be provided at deployment time, reducing the risk of exposure. Then we use secure string for passwords and secrets, and we are acting on recommendation. We use the secure string type for any parameter that handles sensitive information, such as passwords. This ensures the value is encrypted and not stored in plain text. Then this type of the admin password parameter is set to secure string. This ensures that the password is encrypted during deployment and cannot be retrieved or logged in plain text after deployment. And again, we are providing metadata description here. Metadata field includes a description that clearly states the purpose of the parameter. This helps users know exactly what input is expected. And again, avoid default values in sensitive data. Do not provide default values for sensitive information like passwords. So this admin password parameter does not include a default value here. This enforces that a password must be provided at deployment time, ensuring accountability and security. And last but not least, with security post-deployment. Parameters of type secure string and secure object here are encrypted and cannot be read and harvested after deployment. This ensures sensitive data remains protected. By using this secure string, the admin password value is encrypted during deployment and cannot be retrieved in plain text afterward. This protects the password from being exposed in logs, outputs, and through API calls. So if we review the summary of best practices in this example, in this short but yet important example, it follows the following best practices: sensitive data hardening, encryption, clarity, no defaults, and post-deployment security. And finally, the last example on resource naming. Let's show this example here. So, custom resource naming. Why it's important? Resource names often need to be unique or follow specific naming conventions. For example, project, environment, or region-specific names. And hard-coding names and templates limits reusability and flexibility. And how this parameter helps? By parameterizing the storage account name, you allow users to specify a custom name during deployment. This makes the template reusable across different environments or projects without requiring modifications to the template itself. Again, we are using descriptive metadata here with clear descriptions which help users understand the purpose of each parameter, reducing confusion and errors during deployment. So this metadata field includes a description which provides context for anyone using the template. This is especially helpful for teams or when sharing templates with others. So again, we get more flexibility without hard coding. Hard coding values in templates reduce their reusability and adaptability. And parameters allow templates to be dynamic and environment agnostic. We here use and define storage account name as parameter, and we are avoiding hard coding a specific name, making the template adaptable to different use cases. Again, we are using type safety here. We specify the parameter type, which is string in this case, ensuring that the input is validated during deployment. This prevents errors caused by incorrect data types, and this particular template accepts only strings as correct data type. And the type field here enforces that the input must be a string which is appropriate for a storage account name. Now, we could go ahead and improve a bit this particular example. Let me switch to Visual Studio Code. I'll remove this template and let's type the improved version of this particular template example. So we could type, let me make it larger like so. We could type, for instance, actually, let me bring back the previous example and modify it a bit. So let's minimize this resource like so and remove it. Now we'll add the following parameters, right? Then we'll hit return here to add parameters block, and we'll add the parameters for storage account name. Let's do the name first. Again, we'll add colon here and curly braces for the parameters of storage account name. The first parameter will be type. And as I've said, we'll make it string. Again, we'll use comma to separate the parameters. Then we'll add metadata parameter. Again, we'll need curly braces, but let me close this minimap here. So curly braces, and VS Code adds them automatically. Again, we'll hit return to add metadata here. And here we could add the description colon and add the description itself for the user. For example, the name of the storage account. And next we could provide some extra information. For example, must be 3 to 24 characters long and use only lowercase, let's make lowercase letters and numbers. Okay, done. Let's add a comma here to separate this parameter from others and hit return here, and add one more parameter, for example, min length. So here we are requiring a user to name the resource, and the name should contain minimal 3 letters. Add a comma here to separate this parameter, and we'll add a max length here as well, 24 as we've described it. And we'll also add lowercase that will be allow values, actually not values but pattern, and here we'll provide the pattern in double quotes and use regular expression here. We'll insert the caret and then in square brackets from lowercase a to z and from 0 to 9 plus $. So what it does, as I've said, it's a regular expression or regex used to define this specific pattern for validating strings. As I've said, we need to provide only lowercase letters. So this caret symbol first represents the start of the string. It ensures that the pattern matching begins from the very first character of the input. Then the body of this expression, the character set in square brackets that defines the allowed characters. From A to Z means all lowercase letters from A to Z, and 0 to 9 means all digits from 0 to 9. Together, it means that the input can contain only lowercase letters and numbers. Then plus, it's a quantifier meaning one or more occurrences of the preceding pattern. It ensures that the input is not empty and contains at least one valid character. And dollar symbol represents the end of the string. It ensures that the pattern matching continues until the end of the input with no extra characters allowed. So let's continue with our example here. And we've finished this parameter. Let me make it smaller. So we've finished this storage account name parameter. Now let's add one more parameter below. And by the way, we'll need to add a comma here to separate the different parameters blocks. So now let's add a block for the location. Again, we'll start typing in double quotes location, add a colon here, make sure that location on the same indentation level as storage account. As you can see, now it seems correctly indented. And then again, after adding a space, we'll add curly braces, hit return, and add location block here. So first we'll add type. We'll need string here as well. Don't forget about commas to separate the fields. Then let's add default value. For example, as I've said, standard underscore LRS, comma. And again, we'll add metadata here, hit return to make it multi-line, and add a field description, here it is. Then add the description itself in double quotes, for example, the SKU of the storage account. And let's add the information about default SKU. So default is standard underscore LRS. Let's add a comma to finish this field, metadata field, and add one more field. We'll add allowed values. That'll be a list of values, and we'll need to place it inside square brackets, let's hit return to make it multi-line, and add the accepted values. For example, standard LRS, comma, then standard, let me choose LRS, but change this LRS to GRS, comma, don't forget about commas. Let's put it here, and let's add standard ZRS, and that's it. That's enough for this particular example. Again, to finish this parameter, we'll need to place a dot here. So this is our closing curly brace for this parameter. Then we'll add one more. Let's add, in double quotes, kind parameter, and again place it in between the curly braces. Again, we'll add type, string, don't forget about commas, then default value field, here it is. Let's make default value storage v2, and again metadata, again multi-lined, again with description field, don't forget about colons, and in double quotes we'll type a description, the kind of storage account, and again let's add default is storage v2 dot. So again, to finish this parameter block, we'll add a colon here. Actually not this parameter block, but this kind field. We'll add one more field to this parameter, which is allowed values. Again, that will be a list of allowed values. For example, storage, comma, then storage v2, comma, then we could add blob storage, for instance, file storage, and finally block blob storage. So let's remove this extra blank line here and place a comma here. That will finish this block, this location block. Here it is. So we can minimize these blocks, this storage account, and this location account, and this kind account, parameter. We don't need this closing square bracket here, I guess. So let's double check the syntaxes. First, we've got this opening curly brace, and this is closing curly brace for the whole template. Then schema, we've got this comma separator of this field, of this line, this control version, again separated to this comma, content version, sorry, and then parameters block starts. It starts with this opening curly brace and closes with this closing curly brace, right? Then we've got this storage account parameter. Let's expand it. Again, opening curly brace, and here is the closing curly brace. Then location, the same here, and kind, the same here. So we don't need this square bracket, and let me minimize this block. So if we remove this comma, it means that we don't need to continue this block. As you can see now, the underlining that something is wrong is gone. But let's finish this template and we'll add one more block for resources. So I'll add a comma here, hit return, and start typing resources, colon. Again, that will be a list, and inside of this list we'll add curly braces, and inside these curly braces we'll add type field. That will be Microsoft.storage/storage accounts, comma, to separate this value, and add one more, API version 2021-0401, comma. Let's add a name, And as you can see, we've got underlined and selected in red that something is wrong because I forgot to place it in between the double quotes. So name, colon, space, in double quotes again, parameters. Then we'll need to specify a variable in single quotes, storage account name. So close in parentheses, close in square bracket. And by the way, I forgot about opening square bracket here, and close in double quotes, and comma to separate this value. One more value, location. Again, the same structure, double quotes, square brackets, and parentheses. Before parentheses, we'll add parameters, and inside parentheses, in single quotes, we'll add location. Again, comma to separate this value, and one more value, which is sku, multi-lined, name again, and again, double quotes, square brackets, parentheses, comma. No, actually we don't need comma here, we'll need a comma here, and inside this parentheses, single quotes. So can you please pause here and think about the correct continuation of this line? And the solution is here, we'll need to add parameters here and school name here, but typed correctly. And then when we finish this field, we can add one more field, which is kind. Again, the same structure, double quotes, square brackets, parentheses, and single quotes. Can you again please press pause here and think about the correct continuation of this code? And again, the solution is parameters here and kind here. We'll add a comma here and add one more field or line, which is properties. Here it is. Don't forget about colon, and that will be an empty parenthesis. So now we have this close in curly brace here, close in square brace here, and one more close in curly brace for the whole template. Since we finished successfully reconfiguring our initial template, and it looks as follows. Content version now is correct with all the zeros. So let me save this file, and we could actually go ahead and try to run this template here in my Azure account. So let me clear the screen here and try to run this template. So I'll type AZ deployment group create, and by the way, I've removed the resource group, so let me recreate it. So I'll make sure I've logged in first. AZ login command. Seems like I've successfully logged in, and we can continue. I'll clear the screen and create the appropriate resource group. So I'll type AZ group create /. We'll need to specify name again. For instance, ARM demo. Or let's actually name it lit ARM demo. Oops, sorry. I've pressed return too early. We'll need to continue this. Actually, let me clear the screen first and let's continue it with, I'll also need to provide location. So location is EAST-US, not to forget lit ARM demo. Now let's go ahead and try to implement the template we've just created. To remind you, we're keeping the path to this template in template file as far as I remember. Template file variable. As you can see, it's users, my username, demo template JSON file. And if we cat this variable template file, we'll get the template we've just created with all the blocks and needed resources. So let's clear the screen and run the following command: az deployment. Let's validate the file first. Deployment validate \, then resource group, that was lead arm demo, right? That was the name of our resource group we've just created. Then template file, and here we'll place this variable template file. Then we'll need to add one more line with parameters, and we'll add also double dash before parameters. And now we'll provide the parameter with storage account name. So we'll use storage account name parameter. Name. Let's say that we want to name it lead arm storage. Seems like I miss O here. Storage. Lead arm storage. Hit return and see what happens. The following arguments required. Location. I see the issue here. We're using AZ deployment validate, which is for subscription level deployments. For resource group level deployments, we'll need to use AZ deployment group validate. So let's rerun the previous command and add AZ deployment group validate here. Now we get another error here where we get this allowed pattern property is not supported in the current API version. So let's get back to our template and double check. Let's expand this storage account name, allowed pattern, this one. So let's change it to just pattern. Save the file and get back to our console and try to rerun it. Now we get another deployment template validation failed. Template language version must be specified. So that's how you troubleshoot this kind of errors in your template. You just read the error message and try to troubleshoot it. Again, let's get back to our template. So we'll need to add somewhere here the template language. So let's add one more field here. Language version, as we're asked to specify the language version. So we need to specify this language version line to enable the regex pattern validation feature. And I've just Googled this version. We need to provide version 1.9. Again, we'll add a comma here to make everything look clear and correct. And save this file, get back to the terminal window, let's clear the screen and again try to rerun this. Now we get another, so this version is not recognized, 1.9. Okay, let's try to change it to version just 1.0 and try to rerun it. If not, we'll remove the regex expression from our template. Yes, I guess let's remove this one as it's a demo template. We don't need that much specification here. So let's go ahead and remove this pattern. We'll leave only min and max values like so, and we'll remove must be 24 letter. Sorry, not this part, but this, and use only lowercase letters. And let's remove this part and save the template again. Okay, let's give it a try. Now something wrong is with scname. So the template parameter scname is not found. So this error occurs because the scname parameter is defined in the template, but is not being provided during the AZ deployment group validate command. The template expects a value for scname, but it's missing in the command. We have two options to resolve this issue. We can provide all required parameters in this command we are now validating, or use a parameter file. So we could go ahead and create a parameter file, for example, parameters.json, to provide all required parameters. That solution will be clearer approach, especially for templates with many parameters. So let's go ahead and create one more file here in VS Code. I'll open Explorer, click Add. Let's name this file parameters.json file and provide the following. Let me copy. Actually, let's start with curly braces here. And now I'll copy this part, schema and content version and parameters. Let's insert it here. And now in parameters, we'll add curly braces as well, and that'll be multi-line curly braces. We'll add a value. For example, for this particular storage implementation, we'll add our lead arm storage value. Then we'll add another value here, which is required from the previous error message. That'll be SKU name. Again, not typed correctly, SKU name, and provide a value for the SKU name. Let's say that time that'll be standard underscore LRS, comma. Actually, I will need a comma not here, but here. And kind parameter value, which will be, for example, storage v2. So that's how we can evaluate our parameters. And by the way, I've made a typo here. Actually, I forgot about curly braces. So we'll place this storage v2 here. Let's remove this extra blank line. And by the way, here I forgot to specify the parameter I want to use it for. That is storage account name. Again, a colon here, curly braces, and we'll put this value inside of this block, like so. A comma here, then we don't need this one, like this, and we'll need to correct the indentation here. SKU name should be placed here, and kind should be placed here. So the final document looks as follows. Now all the indentation seems to be correct, and we are ready to use this parameters.json file. Let's get back to our terminal, clear the screen here, and get back to this command. AZ deployment group validate, resource group lead arm demo, template file is the same, and parameters, by the way, we'll need to add our parameters file into the variable as well. So let me find this command where we've created template file variable and modify it a bit. So we'll use parameters.json here, and we'll rename this template file into parameters file. Okay, let's rerun this command. We'll add one more line here. Oh, sorry, we don't need this line. We'll just modify the last line. So parameters will be using our $parameters file, like this. Okay, let's give it a try once more. Again, we get an error. So now the following parameters were supplied but do not correspond to any parameters defined in the template SKU name. Okay. Let's now double check our initial file, our original file, this one template.json, and find what could be wrong here. So let me expand these parameters here. Okay, location should be string, default value. Let's change it to use a variable as well. That'll be in double quotes, like this. resource group as empty parenthesis dot location. Metadata description, not SKU, but let's change it, the location of the storage account. Okay, and we'll remove this part like this. Let's remove this line and this line, and let's double check our SKU parameter. So the location, then we'll need to add one more parameter here, SKU name. So I'll press pause here and add the all needed information. Okay, I've done editing it. Now we've got this SKU name after our location. Here it is. So we've got a location block using the variable and SKU name block. Now everything looks as needed. Again, let me save this file and rerun it. So let's give it one more try. Now everything, the evaluation seems to pass correctly. Great, the validation was successful. Now we can proceed with the actual deployment since the template and parameters are valid. So before running or implementing a template, please evaluate it and correct all the errors you can encounter. As you've seen, you can encounter lots of different kinds of errors, and this process of creating a template, it's quite tedious, but when the template is in the working version, you can reuse it as many times as you need. So after you've evaluated your template, you could go ahead and run the following command: az deployment group create / to continue on the next line. Then you'll need to specify, actually, okay, I'll type all the commands needed for deployment. I wanted to modify the previous command, but let's go ahead and type it from the scratch. So resource dash group. Here we specify the resource group where we want to deploy this template. In my case, it's lead arm demo / new line. Then template file, which is template file variable, and oops, sorry, I've pressed return to early. We need one more line here, and we need to specify with double dash the parameters, which is parameters file variable. Okay, let's go ahead and run this deployment. Deployment is misspelled. Okay, one more typo here. Deployment. Hit return once more. And finally, our template started to be implemented and deployed into the lead arm demo resource group with all needed parameters. And by the way, we provide these parameters in this parameters file. So that's a very convenient way to conduct complicated deployments where you've got a separate file with all the parameters which you can modify depending on the situation. So now it, as you can see, succeeded to deploy all the necessary resources we've provided here with all the necessary parameters. And if we go ahead and switch to Azure portal, re-log in into Azure portal and go to home, resource groups, lead arm demo, we'll find lead arm storage resource here, deployed in EAST-to-ES location and type storage account. So now we've modified our initial file to be more flexible and to be more applicable to real-world situations. When you've done, don't forget to remove all unnecessary resources not to be charged. So let me enter the resource group here, make it smaller to get this delete resource group, copy it and delete this resource group as we don't need it anymore because We needed it just for the demonstration purposes. So I hope this demonstration was informative, and I'd like to thank you for viewing. Welcome to the Azure Resource Manager Templates Knowledge Check. Are you ready to test your understanding of Azure Resource Manager or ARM templates? This quick assignment will help reinforce what you've learned about the nature and purpose of ARM templates, key elements and components of templates, and important concepts like idempotency. Each question has one correct answer. After selecting your choice, I'll show the correct answer with immediate brief explanation. Don't worry if you don't get everything right. This is a learning opportunity, and now let's see how well you understand ARM templates. So the first question is, what is an Azure Resource Manager template? Is it a series of Azure CLI commands to deploy infrastructure to Azure, a JavaScript object notation or JSON file that defines the infrastructure and configuration for your deployment, or a script held in Azure Resource Manager to manage your Azure storage account? And the correct answer here is option B, a JavaScript object notation or JSON file that defines the infrastructure and configuration for your deployment. So ARM templates are JSON files, as you remember, and we've created a sample of such a file in previous demonstrations. The next question is, which one of these choices is not an element of an Azure Resource Manager template? Is it idempotent, schema, or parameters? And the correct answer here is idempotent. It's not an element of an Azure Manager template, right? So it's a property of ARM template, not an element. The main elements include schema, parameters, variables, resources, and outputs. And finally, Azure Resource Manager templates are idempotent. This means that if you run a template with no changes a second time. So is it Azure Resource Manager deploys new resources as copies of previously deployed resources, or Azure Resource Manager doesn't make any change to the deployment resource, or Azure Resource Manager deletes the previously deployed resource and deploys them anew? And the correct answer here is Azure Resource Manager doesn't make any changes to the deployment resources. So idempotency means that deploying the same template multiple times will result in the same state, with no additional changes if the resources already exist as defined. So congratulations, you've successfully completed this module, this short course on ARM templates, and you've learned about Azure Resource Manager templates and used them to deploy a storage account to Azure. You made the template more flexible by adding parameters and got output from the execution of the template. So what we've covered in this module was implementing an ARM template by using Visual Studio Code, and we've successfully declared resources and added flexibility to the template by adding resources, parameters, and outputs.